In this video, I'd like to walk you through the process that we use to determine the probability of drawing a sample with a particular sample mean. The technique that we use is very similar to what we used earlier in the class, with one notable exception. Let's dive into it right now and see how it works. Okay, just recall for a moment our formula for determining whether or not an individual score, or determining the probability of receiving an individual score. That formula is given by z equals the score in question minus the sample mean over the standard deviation. The only thing that we need to do when we're working with a mean is we have to change this population standard deviation to the standard deviation of the sampling distribution. The standard deviation of the sampling distribution is equal to this. I'm going to call it standard deviation. I'm going to put SE just to indicate what we're talking about. And that is equal to the standard deviation of the population divided by the square root of the sample size. That's really all we have to do, the only change that we have to make in order to use the same procedure to determine the probability of a particular sample mean. So let's just work through a problem. Let's say that we have a very small sample of 4, and let's say that the sample has a mean of 40 and a standard deviation of 16, and we are looking to see the probability of drawing a sample, the mean of which is greater than 42. Just like all our other examples, step 1 is always to draw out the distribution and what it is we're looking for. So the mean is 40, and we want to find out the probability that we are in this red area over here, the probability that we are greater than a score of 42. All right, now we know what we need to do. The first step in this case is to compute our standard error, and that's given by, in this case, 16 over the square root of 4. That would be 16 over 2, which equals 8. All right, we now have our denominator. Now let's just finish up the problem. We have 42 minus 40 over 8. We get a z-score of 0.25, a z-score of 0.25. If you go to the table, I'm not going to do that here because I want to keep this video short, you'll find out that the probability of drawing a mean that is greater than 42, looking at the table, you'll see that that equals 0.4013. That's all there is to it. The procedure, again, is really the same. The only difference is this guy over here. And maybe it's worth noting that sampling distributions typically have a smaller standard deviation than the population from which that sampling distribution was created. So that's why we have to divide by this square root of n in order to get a standard deviation which is appropriate for our sampling distribution. I hope that you found that helpful.